Hello friends, welcome to this video. Today we are going to discuss about the population inversion in semiconductor lasers. Population inversion means there are more number of atoms in excited state than that of ground state. Such a condition is known as population inversion, and semiconductor lasers are the lasers which emits light when connected in forward bias. So that we have discussed forward bias and reverse bias in the previous video. So today we are going to discuss population inversion in semiconductor laser. So this population inversion, it is required for producing stimulated emissions. Stimulated emissions means if any atom or any system is in excited state, and if we provide the energy to the such excited system, during the de-excitation there are two photons which emitted by the system. Such process is known as stimulated emission, and for that stimulated emission, population inversion, it is the must condition. Means there are a large number of atoms in excited state than that of ground state. So there are different ways in which population inversion is achieved. And in semiconductor laser, there is a different way in which population inversion is achieved than that of other lasers. If we see the helium neon laser and other ruby laser, in that case we provide the external source or external optical source or external energy by means of different ways. That process is known as pumping. And in semiconductor there is another way in which we are achieving population inversion. So it is not a two-level system but consists of electrons and holes in different energy bands. So this statement is about semiconductors. As if you see the different other lasers, helium neon laser, in case of semiconductors there are bands in semiconductors, conduction band, valence band, and these bands consist of electrons and holes. Means conduction band consists of electrons, excess electrons, and valence band consists of holes which are moving inside that particular bands. So in semiconductor there are electrons in conduction bands while holes in valence band. In laser action, in case of semiconductor laser action in semiconductor laser involves energy bands rather than discrete energy levels. As I have already tell you that in atomic laser or other lasers there are discrete energy levels of atoms or any system that we have see, but in case of semiconductor there are bands, energy bands of particular level. So laser action is in semiconductor laser involves the energy bands rather than discrete energy levels. In many lasers, population inversion is obtained by exciting the isolated atom. In case of helium neon laser or ruby laser, we excite atoms by means of by providing the external energy. We are exciting the atoms. In this semiconductor laser we have to excite the semiconductor material which consists of different types of bands. So in many lasers population inversion is obtained by exciting the isolated atom, while in semiconductor excited electrons are not associated with a specific atom but are injected in the conduction bands from the external circuit. Means if we increase the concentration of P and N regions, so there is already there are large number of electrons in N region and large number of holes in P region. So this is the condition by which we are increasing the concentration of particular electrons or holes in particular region. So this is called as population inversion. So therefore conduction band plays a role of excited state while valence band plays a role of ground state. If we compare the semiconductor with the semiconductor laser with the atomic lasers, in atomic laser there are two types of bands, two types of states. one is ground state and excited state. If we compare that with semiconductor laser, so conduction band and valence band plays a role of excited state and ground state for the atom. So population inversion is achieved by increasing the doping concentration of p and n regions. So that's why I have discussed about how to increase the concentration. This is the way by which we are increasing the concentration of electrons and holes in the semiconductor laser. If we increase the concentration or doping concentration of n region, there are a large number of electrons in conduction band. If we increase the concentration of holes in p region, there is a large number of holes in p region. So by means of that, we increasing the concentration of particular ions, that is electrons in p, electron in n and holes in p region. So by which we are achieving the large number of electrons or large number of electrons in conduction band and large number of holes in valence band. This condition is known as population inversion. Population inversion means there are large number of electrons in a conduction band and large number of holes in valence band. So this is called as population inversion in semiconductor laser. So this is about this video. In next video we will see in next article. So this is about this. Thank you.